Welcome. So in this video we will be discussing the problems related to recurrence relation and generating function topic. So let's start. But before you start, in case if you are new, please do subscribe the channel and press the like button as well. What is the particular solution of linear non-homogeneous recurrence relation given by this? So if you look at this, let me rewrite for your convenience how we can rewrite this. Can I rewrite it over here? It can be rewritten as e square minus 4e plus 4 an is equal to 2 to the power n. Okay. They are asking us to find the particular solution. So I will write 1 by f of e. What is f of e? E square minus 4e plus 4, and that I need to operate on 2 to the power n. So this is nothing but 1 by e minus 2 whole square 2 to the power n. Now I hope you notice that if I put 2 directly in place of e, then it will become 0. So this is a case of failure. So I will prefer to multiply it by 1. And there are other ways of doing this problem also, but I am doing this in this way. So what I am going to do next is that I am going to write it 2 to the power n and 1 by, in place of e, I am going to write 2e minus 2 square, and that I operate on 1. This is equal to 2 to the power n 1 by, and now 2e can be written as 2 plus 2 delta minus 2 square over 1. I hope you know that the basic idea of finding out the particular solution. In case if you are facing challenge in the process that I am explaining, you should certainly watch my video in the recurrence relation playlist. So this 2 and minus 2 will be cancelled. What I will get? I will get 2 to the power n 1 by 2 delta whole square, so I will get 4 delta square of 1. Now what did I get in the end? 2 to the power n by 4 and 1 by delta square of 1. So delta square will act like an integral operator. So basically what this will be? This will be 2 to the power n by 4, and if you integrate 1 first time, you will get, let me write it over here, you will get n to the power 1 by 1 integral, and this is the factorial polynomial. If you integrate it again, you will get n to the power 2 by 2. So here also I will get n to the power 2 by 2. So the final answer is 1 by 8 2 to the power n, and n to the power 2 is nothing but n into n minus 1. So which option will be the correct option? A. Don't get demotivated by this long process. This is the good quality question. You may get sufficient time in exam to solve this kind of question. So understand the process. I repeat it. In case if you have not understood, then you should certainly watch the recurrence relation playlist. Let us move to the next question. Now we have a recurrence relation over here, and we have to decide that what is the nature of it. So the recurrence relation, for your convenience, I am writing again an plus 3 minus 2an plus 1 minus an minus 1 plus 3 is equal to 0. So what is the definition? First of all, let me rewrite and then I will talk. I can rewrite it as an plus 3 minus 2an plus 1 minus an minus 1 is equal to minus 3. From this, did you notice one thing? First thing is that this is not homogeneous, because in the right hand side we have minus 3. So this option, because it is saying homogeneous, and this option are not necessarily correct. These are two wrong options. Now is it linear or non-linear? So it is non-homogeneous, of course. Now is it linear or non-linear? It is of course linear, because you look at an plus 3, its power is 1, an plus 1, its power is 1, an minus 1, its power is also 1. So this is linear and non-homogeneous. And of course, we have decided that this is the correct answer, but you may think about that how to decide the degree is 4. So you know how to decide the degree of a recurrence relation. To decide the degree, if you look at this an plus 3, basically this can also be seen as an plus 3 is equal to 2 times an plus 1 plus an minus 1 minus 3. I took these two terms also in the right hand side. Now this term an plus 3 has been written in the form of 4 of its previous term. I mean, you might be thinking how this 4, because this can be seen as 2an plus 1 plus 0, one more term I can write here. Let me make one small correction, because how I am going to look at this, sometimes this is a very important thing and students get confused even though we have decided what is my answer, but just to explain. So we are having an plus 3, so can you see we can write it as an plus 2, but there is no an plus 2, so its coefficient is 0. So 0 an plus 2 plus 2 an plus 1 plus 0 an and plus 1 an minus 1 minus 3. So you have noticed that an plus 3 has been written in the form of 4 of its previous term, like n plus 2, n plus 1, an and an minus 1. So that is why its degree is 4. So the correct answer is C. Good quality question. I hope you understood it. Now the next question is the characteristic root of the recurrence relation R. So this is a direct question. I don't think you will find any challenge. So an plus 4 means I will write what? R to the power 4, the characteristic equation I am writing, and is equal to an plus 2. So I will write 5r square minus 4. How to write it? Again, for every problem, if you face any challenge, I would request you to watch my playlist, and if you already have a clear idea, then you can certainly continue. So I brought all this term in the left hand side. Now I have this is a degree 4 equation, so it will have 4 roots. So how can we find 4 roots? I will write r to the power 4 minus r square minus 4r square plus 4 is equal to 0. So r square common, r square minus 1 minus 4 common, r square minus 1 is equal to 0. So I get what? I get r square minus 1 into r square minus 4 is equal to 0. So r we will get plus minus 1 and plus minus 2. So which option is there? The option A is correct. Next question. Delta square of n square plus 2n. Now I think there are different ways to solve this problem, but the process that I am going to explain to you, actually I am going to use the idea of factorial polynomial, right? You can use the basic definition as well, but I will prefer, because that will also give you idea about how to use the factorial polynomial. So because delta square, n square can be written as n to the power 2 plus n to the power 1. And what is this? If you did not understand, go and check that. 2n to the power 1, because n square in terms of factorial polynomial is written like this. This itself is an MCQ question. They may ask you how this n square can be written in terms of factorial polynomial. So the correct answer will be n to the power 2 plus n to the power 1. So we have delta square, and that we operate on n to the power 2 plus 3n to the power 1. Some of you might be thinking, sir, delta square, it is second degree polynomial, so it will become a constant term and only one option is correct. That is also fine. We can clearly see that the correct option is D, but I am trying to explain to you the process, because in case if you come across a situation where you need to do all this, you should be able to do. So delta square means I need to operate delta on this first, and delta operator acts like a differential operator. So n to the power 2 will give me 2n to the power 1 and plus 3. Now again I need to operate. So 2 and n to the power will give me 1, because it will become a derivative of n to the power 1 is actually in terms of delta will be 1, and delta of 3 is equal to 0. So I will get 2 plus 0. So the correct answer is 2, right? How the delta works, how the shift operator works, all these things I have discussed in the video where I have discussed the inverse operator method. Next, this is again looks like a big problem, but don't worry, it is an easy problem. So they are asking find the general form of the solution of a linear homogeneous recurrence relation with constant coefficient if its characteristic roots are -1 plus minus under root 3i and then -1 and -1. So there are two repeated roots and imaginary root always comes in pair. I think some of you can guess the answer just by looking at the option, but I want to explain to you, right? The option can be guessed easily, but I want you to be clear about the process. So I'm going to write the detailed solution, right? So what will be the general solution? If I write the general solution, and here they are using the coefficient like a, b, small c, small d. So because of this -1 and -1 are repeated root, I will write a plus bn. You know, you must have studied like c1 plus c2n. So here in place of c1, c2, I am using a and bn, and then -1 to the power n, right? Now you can see that this term does not have that, so certainly it will be wrong. Now plus, for imaginary pair of root, like if you have imaginary pair alpha plus I plus minus I beta, you write your solution like rho to the power n and then c1 cos n theta plus c2 sin n theta. This you must have studied. So here again I am going to write the same rho to the power n, and I am using the coefficient here small a small b, so I am writing c cos n theta plus d sin n theta, because this is how they are asking the answer to be written. Now the next thing is that how to decide this rho and theta. So what is rho? Rho is basically under root alpha square plus beta square, and in this case alpha is -1, so I will write -1 square plus under root 3 square. So I will get how much? I will get 3 plus 1 4, so I will get 2. And how do you define cos theta? Cos theta you define alpha by under root alpha square plus beta square. So you get alpha is -1 here, so you get -1 by 2, and sin theta will be beta, so beta again is root 3 by 2. I am writing directly root 3 by 2. So what is theta basically? If cos theta is -1 by 2 and sin theta is root 3 by 2, so theta will be actually 2 pi by 3, 120 degree. How to get that? I hope you have studied earlier, right? So this solution now I am writing, let me use a different color so that you don't get confused. So a plus bn -1 to the power n plus, what is rho? Rho I have got 2, so I will write 2 to the power n, and c theta I have got 2 pi by 3, so it will be c cos, in place of theta I will write 2 pi by 3, so it will become 2n pi by 3. So 2n pi by 3 plus d sine 2n pi by 3. So which option will be the correct option? I think A option, right? Again, you might be thinking that why you have explained all these things. Again, I repeat, there was no need to write rho to the power n. I can clearly see alpha is -1, so -1 square plus 3, 4, and under root that will be 2, so 2 to the power n will be there, right? So just by looking at this I can decide my option. I mean, this is the trick I am discussing. This is a regular process, general process. But suppose you don't want to spend this time and you want to just look at the option and decide. How will you decide? This part you can clearly see that the general solution must have a plus bn -1 to the power n, and this has this part. This also has this part, and this also has this part. So now this will be sorted in the beginning. Next is I write the answer as rho to the power n, and rho here is under root alpha square plus beta square. Alpha is -1, beta is under root 3. So if I take under root alpha square plus beta square, I will get 2. So the general solution have 2 to the power n. And when I look at the options, all the options, only option where we have 2 to the power n is this option. So this will become correct. But anyway, I discussed the general process. Now gentlemen, if you look, we are currently at around 14 minutes of time, and we have discussed 5 problems. So ideally to write the general solution we are taking 3 minutes, which you can minimize to 2 minutes also. So let us see the next problem. The linear homogeneous recurrence relation corresponding to the characteristic root plus minus 1 is, here the options let me write it because it is not written. Now if I have to answer this question, I think I don't feel like I need to explain, but anyway, plus minus 1 root will correspond to what? If I write the characteristic equation, the roots will be plus minus 1 if we have r square minus 1 factor in the characteristic equation, right? This will give me plus minus 1, and another is again we need to have r square minus 1. So there will be two factors r square minus 1. This will be our characteristic equation. So basically it will be like r to the power 4 minus 2 r square plus 1 is equal to 0. So corresponding to this characteristic equation, what will be the recurrence relation? R to the power 4. So I can write it a m plus 4. Here the options are in terms of m, so I'm writing m plus 4. And r square, so I can write 2m plus 2, right? 2am plus 2, sorry. 2am plus 2 and plus am is equal to 0. Let me rewrite it. Am plus 4 minus 2am plus 2 plus am is equal to 0. Am is equal to 0. So which is the correct option? I think C1 is the correct. How to write this? I hope you understood. In case of doubt, please put your doubts in the comment section. Next question, again direct the characteristic roots of the recurrence relation. These are, so what is the characteristic equation? First of all, the characteristic equation is r cube. Here we have n minus 3, so I will write r cube minus 3 a n minus 1, so I will write 3 r square plus 4 is equal to 0, right? I hope you understand how to write the characteristic equation, because we look at the lowest degree term, that is a n minus 3, the n minus 3 term. So the power of r will be 3, and then the powers of r will decrease. Like if a n is replaced by r cube, then a n minus 1 will be replaced by r square. There is no a n minus 2 terms, and a n minus 3, actually n minus 3 is the lowest, so I will just write a constant. Now how will you factorize it? You can clearly see that if I take r is equal to minus 1, so r is equal to minus 1 will be a root, because minus 1 cube minus 3 into minus 1 square plus 4, how much is that? This will be minus 1 minus 3 plus 4, that is equal to 0. So r is equal to minus 1 is a root, mean r plus 1 is a factor. Now once you have got one factor, you can get the other two factors. Like some of the students may do the synthetic division, or I can write directly also. So I can write r square. If I have to factorize here, I can write r square and r plus 1. So r square into r is r cube. Now we have r square, but we require minus 3r square. So I will write minus 4r r plus 1. So it will give me minus 4r square, and this r square will make it minus 3r square. Now we have minus 4r, but there is no minus 4r, so I need to add plus 4r. So I will write 4r plus 1 is equal to 0. If you got it, fine. Otherwise you can simply divide. I hope you know how to find the root of a cubic equation. So I can write r plus 1, and this will give me r minus 2 whole square is equal to 0. So roots will be what? R will be minus 1, 2 and 2. So do we have that option? R is equal to minus 1, 2 and 2. Yes, we have the option D here. So D is the correct option. Next question. Now this is again a very quick question. We have to find what is the value of 1 by e of n. So we know that 1 by e is equal to 1 plus e is equal to 1 plus delta, right? And n is a polynomial, so we know the rule that when we have to operate a function of e on a polynomial, we change it in terms of delta. So I will write n to the power 1. And now 1 plus delta can be written as 1 plus delta to the power minus 1 over n to the power 1. And we always change the original polynomial in factorial polynomial whenever we work with delta. So this is 1 minus delta plus delta square, and there will be so many terms, but basically this is a degree 1 polynomial, so I think after delta we don't require. I have written for you to understand this. So 1 into n to the power 1 is n to the power 1, and minus delta of n to the power 1 is 1. So n to the power 1 is just 1, so I write n minus 1, because I hope you know we have defined this term. So the n to the power 0 is 1, n to the power 1 is n, n to the power 2 factorial polynomial. In case if you have doubt, please watch the previous videos in the playlist. So which option will be correct? The A option will be correct. Good. I hope we are going great and not doing things very fast. If I look at this option here, the recurrence relation this is. So what will be the right answer here? We have done one such problem earlier also. So in the right hand side you see we have a 0, right? So what it should be? It is homogeneous or non-homogeneous? Some of you will be prompted to answer it as a homogeneous, but don't make that mistake. We can rewrite it an plus 1 minus n an minus n is equal to 0. Yes, so you see it is nothing but an plus 1 minus n an is equal to n. Now you can clearly see that this is not homogeneous, this is non-homogeneous. So this A option and D option is cancelled. Okay, now is it linear or non-linear? So clearly it is linear, because an plus 1, the power of this term is 1, an also of 1. So this is linear, non-homogeneous, and degree is 1 because an plus 1 has been written in the form of just one of its previous term. Are you getting this or not? The definition of degree is that an plus 1. So if we want an plus 1, how many of its previous terms would be known to us? Just one term, that is an. So its degree is 1. And non-homogeneous, degree 1, and linear. Yes, this is one more information you can extract from it. From this recurrence relation, that this is not with constant coefficient, this is a recurrence relation with variable coefficient. Okay, what is the general form of the solution of a linear homogeneous recurrence relation with constant coefficient if its characteristic roots are, and don't get bogged down by this long statement. So characteristic roots are 2, 2, 2, 3 repeated roots, then 3, minus 3, and 4. So for this 2 I have to write a plus bn plus cn square, and because they are using this constant, so that is why we are using this constant. Ideally we should use c1, c2, c3, but anyway, because in the statement they are writing it like this, I am also writing it like this. So 2 to the power n for this 2. Now 3, minus 3, and 4 are distinct terms, so I will write d into 3 to the power n, right, plus e into minus 3 to the power n, and plus f into 4 to the power n. So I think this D option will be correct. Here they could have written f into 4 to the power n to make it look similar to other notation. So anyway, so the correct option is D. I hope you know how to write the solution of a homogeneous linear recurrence relation with constant coefficient. Okay, repeated roots and distinct roots, so two possibilities are there. Okay, now D. Now let us come to this question. The linear homogeneous recurrence relation corresponding to the characteristic roots, and now the roots are 3 and plus minus I. Are you liking this ink? I mean, you can suggest this also in comment box, that whether you prefer this ink or this red ink. I think red is brighter. Yes, red. Now color also has become a matter of contention. Anyway, so 3 and plus minus I. So how to write the recurrence relation? This is a different problem, because in the last the roots were given and we were writing the solution. Now they are asking me to write the recurrence relation. So it is easy. I mean, we have done one such problem earlier also in this video itself. So for 3, if I write thickness, please increase the thickness as well. Challenge. So for 3 I will write r minus 3, and for plus minus I, when do we get the root plus minus I? When we have a factor like r square plus 1. Very easy. So you just multiply it, r into r square, r cube, and then plus r, and then minus 3 r square, and minus 3 is equal to 0. So it will give me r cube minus 3 r square plus r minus 3 is equal to 0. So they are writing the answer in terms of m, so this will give me am plus 3, right, minus 3 am plus 2 plus am plus 1 minus 3 am is equal to 0. Which option is correct? D? Okay, good. D, I think D was correct, or yeah, am plus 3, 3am plus 2, am plus 1 minus 3am, because other options are looking similar. No, here plus not correct, here all plus not correct, here am plus 3, am plus 2, so 3 is missing, so not correct. Be careful, these are similar looking options, so don't be in hurry. This is a good question. I hope you will be able to solve it, but let me quickly explain. So 1 by delta of e to the power 3n. So it can be seen as 1 by, and we have seen a result. I don't know whether you remember this. 1 by fe of a to the power n is equal to 1 by fa of a to the power n in case fa is not equal to 0. So I can write delta e minus 1 and e to the power 3n, so e cube to the power n. So I will write 1 by and in place of a now, yeah, you notice a is e cube, so I will write in place of e is replaced by a, so here capital E will be replaced by e cube. E here is the exponential e, so e cube minus 1, and here it will be like e to the power 3 to the power n. So this is, which one is the correct answer? C, because e to the power 3n by e cube minus 1. Good question, quick question also. Next, this is also a very simple and direct quick question we can solve. So delta square, so there are two ways to solve this question. We are going to discuss two ways because that will help you. One is using the definition. So what is the definition of delta of an? The definition is, it is an plus 1 minus an. So delta square, if I apply, I can consider it delta of 2 to the power n. Now delta of 2 to the power n is 2 to the power n plus 1 minus 2 to the power n, which can be seen as delta of, and you see this is 2 to the power n into 2 minus 2 to the power n. Okay, ladies and gentlemen, I hope you are getting. Delta 2 to the power n can be taken common, 2 minus 1 I will get. So I will get delta of 2 to the power n. So we got the same thing. Delta of 2 to the power n is nothing but 2 to the power n. And so if I repeat the same process, I hope you already have got it. It will again be 2 to the power n. So the correct option will be C. This is one way. Another way to solve this question, because delta square 2 to the power n, because why I am explaining this, because in some of the situation this will be more kind of effective. So delta can be written as e minus 1. You all know e minus 1 square 2 to the power n. And this will be, ladies and gentlemen, e square minus 2e plus 1, and I will operate it on 2 to the power n. Now e square of 2 to the power n will be 2 to the power n plus 2. E of 2 to the power n will be 2 into 2 to the power n plus 1, n plus 2 to the power n. 2 to the power this will be 4 into 2 to the power n minus 2. This will be 2 into 2 to the power n. So 2 into 2 will become 4 and plus 2 to the power n. So 2 into 2, 4 into 2 to the power n, and this cancel. What I get is 2 to the power n. Two different ways. You have to decide which one is more effective for you. Next, I hope I am not going too fast. What is the general solution, general form of the particular solution of linear non-homogeneous recurrence relation? Particular solution, yes, PS. So how do you find, ladies and gentlemen? 1 by e square. I hope you understand how, let me rewrite. I think some of you will think that I'm just, not explaining. So e square minus 4e plus 4 an is minus 2 to the power n. So e square minus 4e plus 4 operated on minus 2 to the power n. So if I directly substitute minus 2, what will I get? I will get 1 by minus 2 square minus 4 into minus 2 plus 4. And why I did that, I hope you understand. If you don't, check the previous videos. So this is equal to 1 by 4 minus minus plus 8 plus 4 minus 2 to the power n. So what did I get? I get, gentlemen, 1 by 16 minus 2 to the power n. So which one will be like suitable? They are asking the general form, yes. So this has n coefficient, this has n square, this has n cube. So minus 2 to the power n coefficient is a, so this will be a correct answer, because that 1 by 16 is the constant a, yes. So we have done some interesting problem here, right, in this video. I thought that I will be able to discuss generating function, but I could not. So in the next video, I will be discussing some more problem, and there I will be discussing generating function problem as well. Thank you.